All right, friends, I know you are so excited because I am so excited because I get to talk about my favorite ecosystem, my very, very favorite ecosystem on planet Earth, and that is the estuary ecosystem. That ecosystem that is where the fresh water meets the salt water, and it's rich in life, and it's fantastic, and it's the Chesapeake Bay and all those other cool places. All right. Bodies of water formed where rivers meet ocean. So we get this influx of fresh water meeting the tidal flow of the salt water. Our favorite estuary, yes, I said our favorite estuary is, of course, the Chesapeake Bay. Excuse me, I have to stop now because my daughter has gotten her school pictures. I'll be back.
I love you.
Okay, I'm back. Now, as I said, our favorite ecosystem, estuary ecosystem, is of course the Chesapeake Bay, where we can see that the flow from the Atlantic is going to come in at the mouth of the bay and meet with the flow out from all these rivers. So we have a nice mix of fresh and salt water. It is affected by the tides. And what is so pivotal about estuary ecosystems and their extraordinarily high productivity, remember what I mean about productivity. Productivity means how much of that sunlight are your producers turning into food. So basically how much photosynthesis is going on. So the shallowness overall of estuary ecosystem is really important because it is what makes them so incredibly productive. The shallow water allows for light to penetrate and to the bottom, and we get lots of plant and algae growth and lots of primary producers, which then can support lots of other life. Okay? So there's huge amounts of biomass, which just means lots of life. Bio, life, mass. Okay? Estuaries are incredibly important. Spawning, and meaning breeding, and nursery grounds. Nursery meaning where organisms will raise their young after they've bred. For many species of fish and shellfish and birds, many waterfowl and other birds, for that matter, use estuaries for nesting, feeding, resting as they're passing through on a long migratory journey, and so on. Here you see a salt marsh area in an estuary. It's a typical temperate zone estuary, we have them here, or in the mid-Atlantic, with these wonderful salt-tolerant grasses that we're going to get to know very well later on in the year. We're going to go play around in some of these salt marshes. This is the Spartina grass. There are seagrasses under the surface of the water. Chesapeake Bay is full of salt marsh ecosystems like this. In fact, it is one of the largest systems of connected salt marshes in all of America, in all of the United States. There's another type of estuary ecosystem called a mangrove swamp. We don't have these here. They're more equatorial. Florida has mangroves and so on. Now, a marine ecosystem, my second favorite ecosystem, and I'm sure yours too, right? We all love going to the ocean and having a good time. Marine ecosystems are the true saltwater ecosystems, and these are the ecosystems that are incredibly important for the sheer amount of Earth's surface that they cover. Okay? Light. We cannot overstate the importance of light to the marine biome. Not to any biome, but certainly the marine biome as well. Light can only get through the water a reasonably short distance before it starts just being completely blocked out. And there's only enough light to support real photosynthesis in the very upper parts of the ocean. This is called, and you need this term, the photic zone, the place, the layer of the ocean in which there's enough light for photosynthesis to occur. You're going to find lots of phytoplankton, and algae, but really algae is part of the phytoplankton. So lots of phytoplankton, which this is a picture of lots of different kinds of phyto or photosynthetic plankton, which of course, as we've already stated, is the base of the ocean food web. The phytoplankton is the foundation of the ocean food web. Now, this is a really nice little diagram to understand. So here's the land over here. Now, the zones of the ocean, isn't that a song in Nemo? Let's learn the zones of the, anyway, the zones of the ocean are based on depth and distance from shore. So how deep you can get, how deep you are, and how far away from shore you are. So right here, from here to here, we have what is known as the intertidal zone, and that's the place where you're going to go, where the water will move in and out, depending on whether you have high tide or low tide. So this is that sandy shore where we all play at the beach and we can watch the tide go out and reveal more sand, and it comes in and covers some of the sand up. It's a very difficult zone to live in because you really have to be able to tolerate an extraordinary variety of conditions in order to live there. You've got to be able to survive being submerged part of the time and completely exposed to air part of the time. Very difficult to live there. The coastal zone is where you are when this is the low tide mark. So when the tide is at its lowest, from that point out to where the ocean floor starts really sloping down, that's the coastal zone. And beyond that, out in the very deepest parts of the ocean, you have the open ocean. Okay? Dang it. All right. Now, as I already mentioned, the intertidal zone is the most difficult zone if you're a living thing. It's the hardest place to live in because, again, you have to really be able to survive being wet for a long time, being dry for several hours a day, and then the pounding of the waves is just brutal, as anybody who's been caught in the surf knows. The coastal ocean, however, that part beyond the intertidal zone, extending from the low tide line out to where the open sea would begin, is where we can get some really incredible life forms. There's some places on Earth where we can have really large algae, seaweed, like kelp forests and so on, which are abundant. The coral reefs would be out in this zone. So really, really important ecosystems. Now, the open ocean zone is our largest marine zone, as you can imagine. And the phytoplankton that are in this incredible amount of open ocean water that we have on planet Earth is so much of it, because of how vast the oceans are, that truly about 80 to 90% of Earth's entire photosynthetic activity is occurring in the phytoplankton that exists out here in this open ocean environment. Again, base of the food web. You're also going to find the big fish and dolphins and whales and things like that out here, of course. But because you are way out away from shore once you get out to the open ocean, there's going to be fewer nutrients. So it's tougher for phytoplankton to grow because things like nitrogen and so on and phosphorus that we get from runoff from land are not going to be, as prevalent because we're so far from shore and the source of these nutrients. So nutrients really are a limiting factor out here. They limit the growth. If you don't have much nutrient, you don't have as much growth. Even with that said, though, there's still 80 to 90% of the Earth's photosynthetic activity is occurring here. So there is plenty of growth that occurs. Okay, but now, we saw those ocean zones, okay, and out here where the ocean is really deep, like so deep that here's the top of the water, the light gets down but cannot penetrate all the way down to the bottom, that's called the benthic zone. The benthic zone is just an amazing place. So we're going out in the open ocean, but down deep to where the light cannot penetrate. ocean floor organisms. Now, you can have benthic organisms that are not way out deep as well, because they just live on the ocean floor. Maybe they're up more and close to shore, but we're going to focus a little bit on the ones that are way out deep. You find lots of things that are ocean floor organisms, sea stars, sea anemones, things that cling to the bottom. But in the deepest parts, near the trenches and things like that of the ocean, you're going to be at extremely high pressures down there because of the weight of the water is just enormous on top of these things. So if you live there, you've got to be able to withstand extremely high pressure, very cold temperatures because you don't get that energy from the sun. Now, if you live near a deep sea vent where hot materials from the earth are bubbling up, that's going to make it in fact, a lot warmer. But and also total darkness, no light. Though some organisms emit light all of their own. It was once thought to be devoid of life, but that we know is certainly not true. There are many crazy, weird creatures that live down there. Maybe we'll look at a few videos of them. Okay, so that's your kind of very casual overview of the aquatic biomes, in particular the estuary marine aquatic ecosystems. So thanks for watching, and I will catch you in class. See you later.